Hello everyone and good morning, good afternoon and good evening wherever you are. My name is Prin and welcome to my live broadcast where we'll be learning English together. So thank you everyone for joining, and if you're watching, please do say hi or hello, anything, okay? So I know that you're watching right now. Anyway, for today, we'll be looking at reading, okay? So we'll read an interesting article together, all right? And you get to improve your vocabulary, your phrases, and also your reading skills, so you know how to pick out the main ideas, all right? Now, just before we begin, let's check out the comments area. Okay, so I have one comment here. So hello, Kun Kat. Okay, thank you for joining, and I hope you will enjoy today's live video. Okay, so by knowing vocabulary, you will be able to improve your other English skills, including reading, listening, writing, and speaking. And if you're preparing for a test, of course, by knowing more words and especially reading an article like this, you will read better and you will know more words, which means you can score higher in these tests, all right? Okay, so let's get started. I will show you today's article. Okay, so this one, it's an article on the NASA website, which you can find in the link in the description, all right? So let's look at the title. So this one is a strange looking word, okay? It's actually pronounced Muammua, okay? It's the name of an object in space, and this is what we'll be focusing today, all right? So let's move on. Okay. So this is actually the picture of this object, okay? But we'll get to know more about it in a moment. All right, so let's start with discovery, okay? So the discovery of something is when something is found, especially for the first time, okay? Right. Let's look at this paragraph. What does it say? The first known interstellar object to visit our solar system, 1I 2017 U1, or Muammua, was discovered October 19, 2017 by the University of Hawaii's Pan-STARRS telescope, funded by NASA's Near-Earth Object Observations Program, which finds and tracks asteroids and comets in Earth's neighborhood. Okay, so this is a bit long, right? But we'll break down each part together. Okay, so let's look at the first one. So it says the first known interstellar object. So object is anything, okay? A thing is an object. But in this case, it's an interstellar object. Interstellar means like from space, okay? From, especially like from another area, all right? This is a thing which moves throughout the space. It's not on Earth. And it's a first known interstellar object to visit our solar system. So this means that this object or this thing is the first thing from another solar system or from somewhere else outside our solar system to visit, to come to our solar system. Remember that the solar system is what? The sun, right? And all the planets around our sun, including our Earth. That's the solar system. But here, it's the first object which comes from outside our solar system. Okay, and the name is 1I 2017 U1, and Muammua is like the name that we would normally call, all right? This is like for categorizing. Okay, so it was discovered, it was found on this date by whom? By this telescope, okay? A telescope is an instrument for looking at faraway things, and this is the name of the telescope, and it belongs to this organization, of course, the University of Hawaii. This telescope was funded, so it was given money, okay, by whom? By this program, okay? So this program from NASA gives money to the University of Hawaii, right, to operate this telescope. Okay, so what does this telescope do? Now, this telescope finds and tracks. So it looks out for and also follows, okay, asteroids and comets in Earth's neighborhood. So in this sense, the Earth's neighborhood means the area around our planet. Let's look at the next sentence. While originally classified as a comet, observations revealed no signs of cometary activity after it slingshotted past the sun on September 9, 2017 at a blistering speed of 196,000 miles per hour or 87.3 kilometers per second. So originally, what does that mean? It means at first, okay, at the beginning, this object or Muammua was classified. So it was given a definition as a what? A comet, okay? At first, people thought this is a comet. But then what? Observations, when people keep looking and following this object, they found that here, there were no signs of cometary activity. So it didn't have the look, the aspects of a comet. So they changed the classification, okay? And then it says after it's slingshotted, okay? So to slingshot is like this. So for example, this is the sun, and if this object slingshot, it's kind of like going like this and then turn like that, okay? Here's an object. So this is called slingshot. Okay, so it slingshot past the sun on this date, and the speed is blistering. Blistering means very, very fast, okay? See, at this speed, or you can say at this speed, which is very, very fast, okay? And then it was briefly classified as an asteroid. So Oumuamua was changed, the classification, the type was changed to asteroid. So before it was a comet, right? And then changed to asteroid. But briefly, Do you know what does briefly mean? Anyone? So briefly means like for a short time, okay? So for a short time, this object was called an asteroid. Remember at first it was called a comet, right? And now it's called an asteroid. Until new measurements found it was accelerating slightly, a sign it behaves more like a comet. So it became an asteroid, but then new measurements. So like, when scientists use tools, they use instruments to record new data, and they found it was accelerating. So to go faster slightly is a bit, okay? And if an object goes faster a bit like this, it's a sign, it's a signal. It shows that this object is more like a comet. So what happens is that this object was reclassified again as a comet. As you can see here, see, it's in the comets category. Okay, so at first it was a comet, and then they changed it to asteroid, and then they reclassify it as a comet again. Okay, this is not the actual photograph, by the way. It's like an artist's impression of this object, okay, because it's very far away. You can't take a picture this clear. All right, overview. So now the article will tell us about like the overall details and ideas of this object. All right. So the first confirmed object from another star to visit our solar system, this interstellar interloper appears to be a rocky, cigar-shaped object with a somewhat reddish hue. Okay, so like what they said at the beginning, this is the first known. So maybe there have been many other objects from another system, but we did not track any. Okay, so this is the one that we managed to track. So it's called the first known, or in this case, the first confirmed. Okay, so confirmed by people on Earth that this object is the first one from another star. So not from our solar system, not from our sun. Okay. This interstellar interloper. Okay, interloper. That's an interesting word, isn't it? Do you know what interloper means? Okay, so normally we say an interloper. It's used to refer to like someone who maybe attends a party or an event without being invited. Okay, so in this sense, we can say that here it's kind of like a random object visiting our solar system. Okay, and this object appears, so shows us that it is what? Rocky, so made of rock, and cigar-shaped object. So it's kind of like a cigar, it's long, like this, okay? And with a somewhat reddish hue. So the tone of the color is quite red. The object, named Muammua by its discoverers, is up to 1/4 mile or 400 meters long and highly elongated, perhaps 10 times as long as it is wide. So this object, it's named like this by whom? By the discoverers. So the discoverers are people who found this object. It is up to 1/4 mile or 400 meters long. That's the length. And it is highly elongated. So if something is elongated, it means it is very long, but very thin and not very wide. So things like this is elongated. See, it's long, okay, but it's not very wide. So we say elongated. And then it says perhaps 10 times as long as it is wide. So the length is 10 units, for example, but the width is only 1. So as you can see, it's so long, but so thin. Okay, that's why they say 10 times as long as it is wide. The aspect ratio is greater than that of any asteroid or comet observed in our solar system to date. So aspect ratio is the comparison of two units, two numbers. Okay, for example, here they are talking about the length and the width. So here the length is 10 and the width is 1. So this is an example of an aspect ratio of 10 to 1, okay? So the sentence wants to tell us that this aspect ratio is like greater, so it is higher than any asteroid or any comet that we have seen in our solar system to date. To date means up to now. While its elongated shape is quite surprising, and unlike objects seen in our solar system, it may provide new clues into how other solar systems formed. Okay, so this shape, like what we have said, is elongated, so it's very long but very thin and flat. Okay, is quite surprising, because like maybe we have never seen this kind of object before, right? Unlike objects seen in our solar system. So this object or Muammua is not similar to anything we have seen in our solar system before. And as a result, it may provide or to give new clues, so new details, new information, new hints into how other solar systems form. So how solar systems are created, okay? Other ones, not the sun. Okay. So the observations suggest this unusual object had been wandering through the Milky Way unattached to any star system for hundreds of millions of years before its chance encounter with our solar system. Observations mean like, when we look and we follow something, show that this object, which is unusual, so it's not normal, had been wandering. Okay, so if you wander, it's like you just go for a walk, moving without actually, have a purpose. So just keep on going. If you say you go wandering in the park, it means you just walk, for fun or to relax, but without any proper destination. That's wandering. Okay. Looks like. Okay, we have another comment. So hello, Tik Naja. Thank you for joining. If you have comments, please leave in the comments area, okay? Just say hi so that I know that you're watching and following this live stream. Okay, so let's move on. It says that this object had been wandering through the Milky Way. Does anyone know what Milky Way is? Milky Way is the galaxy that we are in, okay? Our solar system is in the Milky Way galaxy, okay? And it says here that Oumuamua had been, moving around in our galaxy, but unattached. So it's not connected to any star system. Star system is the same as solar system. For hundreds of millions of years, okay, so this one has been moving for hundreds of millions of years, okay, so for a very, very long time before its chance encounter. If you encounter someone or something, you meet that person or that thing. And it says it's a chance encounter. Does anyone know what that means? If something happens by chance, it's what? It means it's not planned, okay? It's by like an accident. They didn't plan to meet. So in this case, the sentence wants to say that Oumuamua, this object, moved into our solar system by chance. It was not planned, okay? For decades, we have theorized that such interstellar objects are out there, and now, for the first time, we have direct evidence they exist, said Thomas Zurbuchen, Associate Administrator for NASA's Science Mission Directorate in Washington in November 2017. So this person said that, for decades, a decade is a period of 10 years. So if we say for decades, it means many, many years, more than 10 years, all right? We have theorized. If we theorize something, it means like we think we have maybe some kind of like idea, okay? But we cannot actually prove it because we have not been able to observe something yet. Okay, so they have this thought that objects from other systems are out there, but now for the first time, they have a direct evidence. So an evidence is what? An evidence is a proof. Okay, it's a proof that there are objects from other solar systems in our solar system. Okay, and this person said, okay, I've got one word, exist. So if something exists, it means that thing is real. Okay, and this person is an associate administrator. So an administrator is someone who manages an organization, and he is an associate administrator. So he probably is not the main administrator, but he helps that person to look after this organization. Okay, and this is the name of organization, that's the city, and that's the date. Okay, immediately after its discovery, telescopes around the world, including ESO's very large telescope in Chile, were called into action to measure the object's orbit, brightness, and color. Okay, so immediately, it means like at that time, without waiting. After its discovery, so when Oumuamua was found, telescopes around the world, so telescopes everywhere, including this one. This is the name of the telescope in Chile, which is the country. If something is called into action, it means that thing is used. So here it's saying that all the telescopes around the world are used to what? To measure, to get the numbers, the data about what? The object's orbit. Okay, so an orbit is like this. For example, this is the sun. Okay, and here's an Earth. So the Earth is orbiting around the sun. This is the orbit. Okay, so this means all the telescopes around the world are used to track and measure the orbit of Oumuamua, and also to track the brightness. So how easily it is to see, because if something is bright, it's like probably visible from afar, and the color of that object. Urgency for viewing from ground-based telescopes was vital to get the best data. Urgency is like the need to hurry. Okay, for viewing, so watching from what? Ground-based telescope. If something is ground-based, it means it is situated on the ground. So telescopes which are ground-based means like they are built on the ground, maybe on the mountain, okay? Not in space. Some telescopes are like a satellite in space, but these telescopes are built on the ground. So they say ground-based telescopes. It was vital. Vital is the same as like important or essential to get the best data. So to get like the best information, all right? What's next? Combining the images from the FORS instrument on the ESO telescope using 4 different filters with those of other large telescopes, a team of astronomers led by Karen Meach of the Institute for Astronomy in Hawaii found that Oumuamua varies in brightness by a factor of 10 as it spins on its axis every 7.3 hours. So combining comes from combine, means to put things together. And in this case, they put pictures or images together from this tool, this instrument, which is found on this telescope, okay, and they use 4 different filters. So a filter is something to like, to sort out information, or in this case, maybe they make certain parts of the picture easily seen, okay? A filter can sort out information like that we don't want, can remove maybe certain color, certain tone, certain objects. Okay, using 4 different filters with those of other large telescopes. Those, there were those here. Does anyone know what it refers to? Any guesses? Those. So in this case, the word those refers to what? Refers to images, okay, of other large telescopes. So here, the sentence wants to tell us that the scientists, they put pictures together, including pictures from the ESO telescope and also pictures from other telescopes on Earth. A team of astronomers, okay, a group of astronomers. So astronomers are people who study the stars, the space and stuff like that. And this is the leader, and she works here, Institute of Astronomy, okay, in Hawaii, which is a state and island. Okay, and the team found that they discovered that Oumuamua varies in brightness. So if something varies, it means like there is a variation, a difference, okay? And there is a difference in brightness by a factor of 10. So there is a lot of change in brightness of this object. Why? Because it spins, so to go around itself on its axis. Okay, axis is like the imaginary middle line. So for example, this is an object, and the dotted line here is called an axis. So this object spins like this around this imaginary line. We call this imaginary line axis. Okay, and it spins completely in one rotation using 7.3 hours. No known asteroid or comet from our solar system varies so widely in brightness with such a large ratio between length and width. Okay, so any asteroid or comet that we know, okay, by saying no known, it means there is none of the asteroid or comet that we know, that we have observed, that we have looked, okay, from our system, which varies or changes in brightness so much as this one. So it's to say that Oumuamua shows difference in brightness so much, okay, much more than any other objects we have observed inside our solar system. So here says a large ratio between length and width. So this is like what they said earlier, the word aspect ratio, right? They said it was 10 to 1. This is the ratio of the length and the width. The most elongated objects we have seen to date are no more than 3 times longer than they are wide. So here they're comparing that things in space which are longer than they're wide, the most that they have seen is only 3 times longer, okay? But this one is 10 times. So it's much more than things that astronomers have seen before. And what else? This unusually big variation in brightness means that the object is highly elongated, about 10 times as long as it is wide, with a complex, convoluted shape, said Meach. Okay, so here is saying that the difference or the variation is unusual. It's not normal, okay? The difference in brightness. So this means, this shows that the object, Oumuamua, is highly elongated. So like what we have seen before, elongated means like it is very long, but it is thin and flat. Okay, so this is just to say the thing we have read before, 10 times as long as it is wide, okay, with a complex, convoluted shape. So this object is complex. The shape is not like simple. And convoluted also means like complex as well, and it's like with maybe lots of details like that. That's why it's convoluted. It's not just a simple, maybe a circle shape or something. And that person said, so this astronomer said. We also found that it had a reddish color similar to objects in the outer solar system, and confirmed that it is completely inert without the faintest hint of dust around it. So the group found that the color of this object, Oumuamua, is reddish, so it is quite red. And this is similar to, so it's like things that they found in the outer solar system, on the edge of our solar system, okay? And they confirm, they're sure that Oumuamua is inert. So like, the object doesn't react with any other things completely, totally, without the faintest hint of dust around it. So they did not find any hint. So just like bits of dust. Dust is like when you kick the sand or something and you see things blowing up. That's dust, okay? So here they want to say that this object is inert. It doesn't react with anything. It's just like a big chunk of rock or something, and there's no dust gathering around it. These properties suggest that Oumuamua is dense, composed of rock and possibly metals, has no water or ice, and that its surface was reddened due to the effects of irradiation from cosmic rays over hundreds of millions of years. So these properties, these things that they have found, show us that Oumuamua is dense. So, inside is the particles, everything is very close together. That's dense. Okay, composed of, made from what? From rock and maybe some kind of metals. And there is no water, no ice on Oumuamua, and the surface, so the outside of Oumuamua is reddened. It's red. Why? Because the effects, so the consequence of what? Of irradiation. Irradiation is like when lights or maybe some kind of radiation affects something. So here, the color of Oumuamua is red because of some kind of light or radiation which shone onto its surface, okay, from cosmic rays. So this is like some kind of rays in space, and it was affected by this for a very long time. That's why the surface changed to red. Okay. A few large ground-based telescopes continue to track the fading object as it receded from our planet. So the telescopes on the ground that are large, a few is like 2 or 3, okay, continue to track. So they keep on following the fading object. So probably it's saying that, the object is like a bit getting further away from our planet, from Earth. So it's fading. The brightness gets lower and lower and lower as it receded. So to recede is like to move away, okay, from our planet. See, like what I've said. 2 of NASA's space telescopes, Hubble and Spitzer, tracked the object traveling about 85,700 miles per hour or 38.3 kilometers per second relative to the sun. So it's talking about the telescopes which are in space, and these are now not on the ground, okay? And it's talking about Hubble and Spitzer telescopes. Both of these telescopes are in space. So these telescopes followed the object which traveled at this speed, so it's very fast, but it says relative to the sun. So it's not like its speed by itself, but it's the speed when compared to the movement of the sun as well, okay? That's why it says relative to the sun. Its outbound path is about 20 degrees above the plane of planets that orbit the sun. Okay, so the path that it is traveling out. So if this is our solar system, this object is traveling away. So the way that this object is traveling away from our solar system is about what? 20 degrees. So that's the angle, okay, above the plane of planets. So for example, this is like a plane, okay, a flat area, and then we have the sun, we have other planets like this. So here is saying that the path, it makes a 20-degree angle, something like this, okay? Okay, so that's the plane, okay, the flat area of the planets that orbit the sun. So planets that orbit the sun are like our Earth or Mars, Jupiter, and so on. The object passed Mars' orbit around November 1st, and we passed Jupiter's orbit in May 2018. So Oumuamua has already passed the orbit of Mars, which is a planet, and on this date, and we also passed the orbit of Jupiter on this date. Obviously, this date had already passed, so Oumuamua had already passed Jupiter's orbit. It will travel beyond Saturn's orbit in January 2019 as it leaves our solar system. Oumuamua, we head for the constellation Pegasus. So it will move beyond, so it moved like far away from the orbit of Saturn on this date, and then it goes out of our solar system, okay, and we'll head for, so we'll go to what? The constellation called Pegasus, okay? A constellation is like a group of stars. Preliminary orbital calculations suggest that the object came from the approximate direction of the bright star Vega in the northern constellation of Lyra. Okay, so preliminary is like the first, the early, so it's not a final calculation yet, okay? So the astronomers calculated the orbit of Oumuamua, and it was found that Oumuamua came from the direction. So, they came from this area, but they say approximate. So it's not very precise, not very accurate, okay? Of the bright star Vega. So Vega is a star. So they want to say that, from the early calculation, they found that Oumuamua came from the area of this star called Vega, which is in the constellation or group of stars called Lyra. So Vega is in Lyra, okay? However, it took so long for the interstellar object to make the journey. Okay, so however is like a word we use to connect sentences, right? But to show contrasts, to show differences. Okay. So it took so long. It took a long time, okay, for the interstellar object. The words interstellar object here refer to Oumuamua because this comet came from another system, right? To make the journey or the trip. Even the speed of about 59,000 miles per hour or 26.4 kilometers per second. That Vega was not near that position when Oumuamua was there about 300,000 years ago. Okay, so even though Oumuamua came from the direction of Vega, but it took so long to travel, right? Because the space is very, very big. So even though Oumuamua was traveling very fast, okay, if we go back 300,000 years, what happens? In that area where we can see Vega now, 300,000 years ago, Vega was not here. It was like somewhere else, okay? So even though the astronomers found out that, okay, Oumuamua, this comet, came from Vega, but if we go back in time, if we go back 300,000 years, okay, so the comet would be in another position, but that position, 300,000 years ago, there would not be the planet Vega, because the Vega itself, even though, sorry, not the planet, the star, because Vega, the star itself, also moves, okay? So 300,000 years ago, Vega was somewhere else, but right now it's in that area, all right? Astronomers estimate that an interstellar object similar to Oumuamua passes through the inner solar system about once per year, but they are faint and hard to spot and have been missed until now. So astronomers, they estimate, they guess from all the numbers they have that objects from outer space that are like Oumuamua passes through, so go through the inner solar system, so the center part of our solar system about once per year. So they guess that there must be at least one interstellar object, all right, going through our solar system at least once. But they are faint and hard to spot. So faint is not very bright, okay, and hard to spot, so you can't see them easily and have been missed. So like what they mentioned is it's not bright and it's not easy to see. So what it means, yes, they guess that there have been many objects like this, but we missed them. We did not see them in our telescopes. It is only recently that survey telescopes such as Pan-STARRS 1 are powerful enough to have a chance to discover them. So recently, not long ago, telescopes that are used to survey, to find maybe new objects, okay, such as this one, that's the name. are powerful enough, so like strong enough, good enough to what? To have the opportunity to find these interstellar objects. Okay, so before, maybe we didn't have the advanced technology that we have today. Okay, so that's why we didn't find these objects. But astronomers think there are objects from other solar systems. This is not the first one, except that this is the first time we managed to observe and track them. Okay. And okay, so I have a comment from Papatra. I like this topic. Thank you for watching. And you can suggest other topics, if you enjoy this section. Okay, and to everyone, if you enjoy this live feed, please also share it. Okay, so all right, so let's move on. I think we have a bit more here. Okay, so what a fascinating discovery this is, said Paul Schroeder, manager of the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory, Pasadena, California. Okay, so this person, he said that when we found or when we discovered this object, it was fascinating, very exciting, very interesting. That's the meaning of fascinating, okay? And Paul Schroeder is the manager, so he manages this center. Okay, so from the name, Center for Near-Earth Object Studies, so they probably focus on things which are near our Earth. Okay, and this center is situated here. Okay, and that's the city and that's the state. It's a strange visitor from a faraway star system shaped like nothing we have seen in our solar system neighborhood. So here's saying it's a visitor. A visitor is someone who comes for a while, like if you have a house and then someone came to knock the door and then they talk to you and then they leave, that's a visitor. So this is a visitor which is strange. So it is not normal from a faraway star system. Star system here is the same as a solar system, and far away, that means the distance is very great. And its shape is nothing like we have seen. So we have never seen this shape before in our solar system neighborhood as well. So neighborhood is like the area around something. In this case, if we say our own solar system neighborhood, it means the area around, not just in, but around our solar system as well. And here's the last part. How Muammua got its name. So why do people call this object Muammua? The object was officially named 1I 2017 U1 by the International Astronomical Union, which is responsible for granting official names to bodies in the solar system and beyond. So this object, this comet, the official name, okay, like the name that they use in formal situations is this one, okay? And this name was given by this organization. This organization, its role or responsibility is to give names to bodies. In this case, bodies is not like a body of a person, okay? Body here means any object in space. See, they say bodies in the solar system and beyond. So any object inside our solar system and any object beyond, so any object outside the solar system. This organization, International Astronomical Union, will give names to those things, all right? In addition to the technical name, okay, so the first one, like what we said, this one, 1I 2017 U1, that's the technical or official or formal name, okay? But there's also another name that, it may be easier to remember because this is just like numbers, right? It's hard to remember. So in addition to, so other than the technical name or official name in this case, the Pan-STARRS team, so the team who used this instrument, okay, dubbed it. Dub means call, okay, to call it. Call it Muammua. Pronounced means to say, okay, say it Muammua, which is Hawaiian for a messenger from afar arriving first. So Muammua is not English, it's Hawaiian. It's in the Hawaiian language, okay? And this word Muammua means a messenger from afar. So a messenger is someone who has a message, who gives news. From afar means from somewhere that is very far, not near here, from somewhere that has a lot of distance. Like in this case, afar means what? From outside our solar system. So let's say it's afar, all right? And arriving first, so coming here first. So by naming it Oumuamua, I think that's like a good name, don't you think? Because it shows that this object, right, gives us new ideas, new information about something that is not in our solar system. So in effect, it is a messenger and it comes from a great distance. And it's the first one that we managed to observe. That's why the name Oumuamua is suitable, don't you think? Okay, so that's the end. But before we finish, I have some questions for you to test your understanding. All right, I'll write them up, and you can have some time to answer them. All right, just a moment while I write these questions. All right, so these are the two questions relating to this article. If you know the answer, please type it in the comment area. All right, just have a guess. It's okay if you got it right or wrong, okay, because you will learn and you will also get to practice your reading skills. Remember, if you need to revise, you can click on the link in the description. Or if you have been listening throughout this live stream, you will probably already know the answers. All right, have a guess. All right, everyone, let's find out the answers to these questions. So let's go back. The first one is true or false, Oumuamua is the first object to visit us from outside our solar system. What do you think? Is this true or is this false? Is it the first thing to come to our solar system from outside? What do you think? Okay, the answer to this question is actually false, to be accurate. Why? Because if we go back to our article, just a moment. Okay, so here they said it's the first confirmed object from another star to visit our solar system. So it's just the first one that is confirmed, but it's not like the first one ever. And if we look at here, okay, it says that for decades they have thought, the astronomers have thought that there are many objects from other systems, but they didn't have like the evidence yet. Okay, so there are many proofs in the article. Okay, and here too. Astronomers estimate that an interstellar object, okay, similar to Oumuamua, passes through the inner solar system about once per year. So there are objects, things, whether there are asteroids or comets, which go through the center of our solar system, but that thing comes from outside. They think that there is at least once per year, but we haven't managed to track them yet until Oumuamua. Okay, so to go back, the correct answer is false. And what about the second one? What best describes the shape of Oumuamua? What do you think? Any answers? Okay, one answer to this question is of course what? Elongated. Elongated. So if something is elongated, it means what? It is very long but very flat or very thin. Okay, or we can say cigar-shaped. Cigar-shaped. Okay, so if you had these answers in mind, you are correct. Okay, so either elongated or cigar-shaped. All right, so that's the answers. Those are the answers to the second question. All right, so this brings us to the end of our live broadcast for today. Thank you so much for watching, and thank you for all the comments and the shares. And I hope you found this live broadcast beneficial, especially to your reading and your vocabulary skills. Okay, if there's any other topics, okay, that the topic doesn't have to be reading, okay, that you would like me to teach. If you want me to focus on maybe vocabulary or grammar or writing or anything, please do tell me. Just type your needs in the comments area. All right, and then I'll read every comment, and of course we'll probably focus on that topic that you suggested. Okay, so that's it for today. Thank you again for watching, and please take care until next time. Okay, I'll try to go live as often as I can, so I'll see you around. All right, goodbye.